In this video, we're going to talk about ZRemesher. ZRemesher is an automated retopology tool in ZBrush. It allows us to automate the process of creating an organized, low-resolution model, and then we can use that for animation or posing or creating UV maps and rendering outside of ZBrush. There's a variety of reasons as to why you would want to retopologize your mesh, most of them being you need to get your model out of ZBrush into a game or film pipeline. We would also want to retopologize something like a Dynamesh so we could then use posing tools on it, because you can't easily pose a 3 million polygon model. However, if you have subdivision levels with a lower resolution that's an organized 3D model, you can easily mask out areas and pose. If I open the subtools here, I have a folder called Remeshed, and if I open this Z tool, and we'll solo the rest, step down our subdivision levels with Shift-D, you'll see that here we have an organized base mesh. We have edge loops that flow around the major facial shapes, and it's only 6,000 faces. However, we have multiple subdivision levels, which carry all the high-resolution detail of our Dynameshed model. Now, because we have a low-resolution cage, we can step down. We can take our Move brush and make big shape changes, so we can carry on the design process on an organized model, and then step back up and see those changes propagate into the higher subdivision levels. We can also, as I said, pose the model, so I can easily isolate something like the head, for example, using a mask. Control-click on the background and go to Transpose Rotate. And then using Rotate, I can pose the model. And this is not something that's easy to do if you have, like I said, 3 million to 6 million polygons. It just isn't a simple process to pose something that dense. In many cases, it won't be possible at all. So now that we have a good understanding as to why we would want to retopologize, let's take a look at how we actually do it. Here I've got a copy of the mesh. And this does not have subdivision levels. This is actually formerly a Dynamesh. If we go into frame mode, you can see that there is no organized topology. It's just a blanket of little quad faces. Now, there's a variety of ways of retopologizing in ZBrush, using edge extrusions in ZModeler, using the topology brush, using Z-sphere retopology. ZRemesher is the easiest. It is automated, but it takes an enormous amount of user input to customize the process, so you have a lot of control over the resulting topology. So what I always do is duplicate my mesh before I retopologize it. That's because we're going to lose our polypaint, and of course we'll lose our high-resolution details. So we would want to subdivide and reproject our model onto the high-res to capture all that detail in higher subdivision levels. So we keep that around, and I just turn off the visibility. And I'll turn off visibility on the eyes and teeth as well. So we access ZRemesher by going to Z-Tool, Geometry, ZRemesher. Now we have the ZRemesher button here, which executes ZRemesher. It causes the program to run. We have Legacy 2018. Now, in ZBrush 2018, this code was rewritten to take better advantage of hard surface modeling and just give you a better result. This is just here in case you need to go back to the old version. You will likely never need to use this button. I have never found a need to go here because the new ZRemesher is so effective. Perhaps you have something that you retopologized before 2018 and you need to get something comparable, you might use that button then. Freeze border will freeze the border edge of the mesh. Now, this is used when you've got two parts you're remeshing that you want to merge together in Maya, perhaps. So you want to keep the number of polygons along the edges consistent between the two parts so you have the points to merge together. Freeze groups will freeze the group borders. That freezes the border of a polygroup rather than the border edge of a mesh. Now we have keep groups that will keep the existing polygroups in the remesh. Keep creases, which will keep any creased edges, and detect edges. Now these are useful for retopologizing hard surface, which we'll see in a later demonstration. Most importantly, now we have target polygon count. This sets the polygon count that we're aiming for. Right now our mesh is 3 million faces, almost 4. I can set this to, let's set this to 20,000 faces to start with. We'll hit enter. Now, we have these buttons down here. If we have it set to adaptive density, this will adapt the density to the details on the model. I can change from inputting a direct value to doubling my current value. I can make it the same polygon count as I already have, or I can half my current polygon count. but we don't want to use these. Sometimes half can be useful if you want to reduce an existing retopology, but generally it's best to directly dial in a poly count. So we'll set it quite high. We'll set it at 20,000. Adaptive size allows the quads to not just be perfectly square. It allows some rectangular quads to exist. So leaving that at 50% is most of the time just fine. Curve strength uses the ZRemesher guide curves, which we'll talk about later in this video. This determines how strong the curve influence is. Use polypaint allows us to use polypaint to define areas that will have more density in the resulting remesh, and again, we'll talk about that later. We just want to do the very, very basics in this first demonstration. So set to 20,000 faces. I will click ZRemesher, and it will start to process. Now, depending on the complexity of the underlying surface and the polygon count, this could take a little bit of time. You'll have a progress bar up here at the top of the screen. ZBrush looks at the shape changes in the model and then determines where it will place edge loops. So the algorithm is quite good at identifying facial features and identifying plane changes and putting an edge loop around those plane changes, which is typically what you want to do when you are manually creating a remesh. Now, areas like the eye sockets here, it's always best, and areas like the mouth, it's best to have a very clearly delineated plane change where the eyelid rolls back to the inside of the eye. That will help you get a good loop around that area. If you're not getting a good loop there, you might want to go in with your sculpting tools and just accentuate the inside of the eye so there's a real cliff or ledge there. So we'll let this finish processing, and we'll come back once it's complete. And here we are. Right away, you see the polypaint information goes away. We go into frame mode. We're no longer seeing just a blanket of quads. We now have an organized network of loops that go around the face, around the eye area. They flow up here over the eyelid. We've got loops containing the nostrils, and we have loops around the mouth. Now, this is quite dense. I could most likely want to make this a lower resolution model. Also, I have X symmetry turned on. When I executed my symmetry, or when I executed ZRemesher, symmetry was turned on. Thus, it created a symmetrical retopology. If you have an asymmetrical mesh, then you would want to have your X symmetry turned off when you do your remesh. So look, for example, here, we actually do have a fair bit of asymmetry in this model. Here in the mouth area, we've got asymmetry in the brow area. So if I turn my X symmetry off, and we'll run this remesh again, I'll set this to 10,000 faces this time. Now, usually you want your topology to be symmetrical. And if you're working on an asymmetrical face, like a head scan, for example, which I will demonstrate, you would probably generate your topology on a symmetrical version of the model and then shrink wrap your symmetrical topology onto the asymmetrical original. I just want to mention that now because an asymmetrical topology can actually be a bit of a challenge if you're working with something like a character head that is not blatantly asymmetrical. For example, a big horn coming out of one side of the head or some deformation on one side of the head and not on the other. So usually you want to have your X symmetry turned on when you remesh, but I will turn it off this time and we will ZRemesh again, this time with 10,000 faces as our target polygon count. And here you can see the topology has completed. It is an asymmetrical remesh this time, and it's considerably lower resolution. It is, once again, capturing the major shapes of the face using edge looping. Anytime we've got a socket here, it's trying to create an extrusion pattern or a loop around that socket. It's looped the ears relatively well and the eyes. Now, as I said, an asymmetrical remesh is not always desirable because you don't end up with a center line. And without a center line, it's hard to do things like mirror UVs, or it can make rigging difficult. There's a variety of reasons why it's not desirable necessarily to do your remesh without symmetry. So let's undo that. And we'll turn our X symmetry back on, and I will remesh again, but this time I will have symmetry turned on, and I will have it set to 10,000 faces. So we'll remesh one more time, and we'll come back when that process is complete. And here we see that topology has completed. We go into frame mode, and you can see the resulting topology. It is, as I said, symmetrical, but that's not necessarily a problem because we can shift this topology around and re-project it onto an asymmetrical mesh. Now, one thing I do want to point out here is that we are losing poly count by wasting faces on the underside of the mesh here. If you're working from a Dynamesh, it's more likely than not the bottom will be capped. So how can we fix that? So if I undo my retopology, we'll turn off frame mode. You see we've got the underside of the mesh here that has a cap on it. Well, make sure that your Dynamesh is turned off. So we'll go to Dynamesh, make sure it is not turned on. And then the simplest way of getting rid of this is to go to B for brush, S for slice, and we can select the slice curve brush. Click OK, and that will replace my Control Shift click drag brush with this curve. Now, if I press the space bar, I can move the curve around. Everything on the feathered edge of the curve is going to be sliced. Everything on the other side will stay the same. So if I were to draw an edge like this, then go into frame mode, you see it's sliced and polygrouped that angle. So let's do this again. I will turn my frame mode off, Control Shift click and drag, and I'm just going to tap the Alt key once, and that creates sort of a knot that allows me to create a little curve here. So it helps me create a nice sweeping line along this edge. There we go. Let go of the brush, and it will slice along that curve. And there we go. If we go into frame mode, you can see we have a poly group here. I'll turn off line inside the polyframe button so you can actually see it. So if I Control Shift click on that poly group, it'll isolate it. Control Shift click on it again, I can invert so just the head is visible. And you see it's hollow. But you see, oh, actually we didn't quite catch everything because it's scalloped up in there. So this is still part of the same poly group. So what I would need to do in this case is just come around to the side here, turn off perspective, and let's draw a new curve. Press the space bar and move it up here, and I'm just going to draw my curve through here and then carry it up along this angle so we get a nice clean slice there. There we go. So now if I Control Shift click on this, I can hide that, and we've got a hole at the bottom of our mesh. Now we simply go to Geometry, Modify Topology, Delete Hidden. We'll turn off frame mode. Now let's run that retopology again, and we will get the full benefit of all of our ZRemesher faces on the head, and we're not wasting any on the underside of the mesh. So I will click ZRemesher again, target polygon count of 10, and here we have our remesh. If we go into frame mode, you can see the resulting polygons. Now, I want to point out that even though we have set it to a polygon count of 10, sometimes it doesn't actually get to that value. Here we've got 18,000 faces. It's hit a little bit higher. If we go to our subtools and mouse over the model itself, we can see that it's 18,827 polygons. Now, the reason that happens is that ZRemesher is not a manual retopology tool. As I said, it is an automated tool that gives you a lot of user input. What ZBrush does is it looks at your overall shape and then evaluates it based on these options here. So we set a target polygon count of 10. With adaptive turned on, it will factor in the adaptive size of the faces more than target polygon count. So this is ensuring your faces are all square. You can raise or lower that or disable it entirely and try and get closer to that target count. ZBrush's main concern is to give you the best possible edge flow while maintaining the volumes of the shape that you're remeshing. Now, I could turn on half here, and I could try and half size this, or I could try and retopologize this again with ZRemesher and setting it to 10,000 faces. So I could set it to 10 and then remesh again, or I could half size it. So if I were to remesh it now with adaptive turned off in 10, we could probably get closer to our 10,000 faces. It may still not exactly hit. As you can see, it still isn't exactly hitting that. So if I set it to half size in ZRemesh, you see we're losing the overall forms that we wanted. But at half size, now we get to 9,108. So let's say that this is the polygon count that we wanted. Now, I have already stated that we have a somewhat asymmetrical model in the first place. So if we go back to our subtools, we have our original Z tool here. Let's turn off frame mode so we can see it clearly and turn on solo. We have our poly paint and our forms. So this is how we can recapture all of our details into this topology. Turn off X symmetry and go into frame mode. And what I will do is I will mask out this side of the face so we're not affecting it. I'll take the move brush and let's turn off solo, turn on visibility on our high res, zoom in, and what I want to do now is I want to take my move brush and just scoot the shapes ever so slightly so they're lining up with the forms on the opposite side. Now, there's not a lot of asymmetry in this particular model. For the most part, it's relatively symmetrical, but there's a few little places around the mouth and around the eyes and brow that had some asymmetry baked into them. So what I will do is I will position the mesh and the edge looping so it lines up a little bit better. And I masked that center line so we can keep that center line intact. I don't really want to lose that. There we go. The ears are pretty good. Now, what I will do is I will go to Subtool, Project. We'll turn off color for this one, and I'm just going to project all, and it will project the unmasked faces onto the high res underneath it. There we go. Let's turn on solo. And anywhere that we've got problem areas, like maybe this eye here, I'll scoot this around and adjust. Now, these eye loops are not ideal, but we will talk in a moment about how we can get a better result out of our edge loops in these particular areas. Do a little bit of smoothing here. Clear my mask. Now I will add a subdivision level with Control D. I will turn on color, and we'll turn off frame mode. Now, I still have that high res. The visibility is turned on. Make sure visibility is off on everything else because it will project to any visible subtool, and I only want to project my remeshed head onto the high-res head to capture my color and my detail. So we'll go to Z Project, color is turned on, and click Project All, and say Always Yes. And you'll see it starts to pick up the poly paint. Divide again, Project All. Now this little area here, it's not successfully projecting. That's not a problem. I can actually smooth this out and then get a better projection on that by adjusting my range in just a moment. Here we go. So what I will do now, take my smooth brush, make sure RGB is turned off. If you don't turn off RGB on the smooth brush, you're going to end up smoothing your poly paint. You'll blur your poly paint. So I'll just take the standard brush and push this in a little bit so it's a bit closer to the mesh underneath. And project all. And you'll see this should capture detail better now. Let that finish processing. And there we go. You see we're starting to capture that detail. Now I'll add another subdivision level because currently we're only at 144,000 faces. But if we mouse over our original is actually 3 million. So we'll divide again. And that gets rid of some of those facets that we're seeing in the nooks and crannies, and we will project all. Now we start from the lowest subdivision level and project each level as we add it, because if we just divide it a bunch of times and then project, it'll take longer because ZRemesher is having to compare all of those vertices at one time, and it won't necessarily be as accurate. You get a better result if you divide and project than divide and project. So ZBrush is doing its process on this, and in a moment, you'll see that we start to pick up even more of our fidelity in the poly paint as well as the surface detail and the wrinkles and all the other areas. And there we go. We're starting to get more and more fidelity. If I go back to my turn off solo, go back to my subtools, turn off the high res, turn on the eyes and the teeth. Now we've got all of our subtools and we have a remeshed version of our model. I can step down my subdivs, step back up my subdivs, and I've maintained that center edge line, that edge there, the one that runs straight down the middle of the model. That's really something that we want to hang on to, just in terms of making life easier, like I said before, for rigging and for UVs. So that's ZRemesher in a nutshell. Usually we are going to retopologize something, get it as close to our target polygon count as possible, and then project it back onto an existing mesh. Predominantly, I use ZRemesher when I have created something using Dynamesh and I want to then have subdivision levels to carry on my sculpting process, not necessarily because I need an animatable topology. However, it is possible to have a lot more control over that topology that we get than what we just saw. We can use guide curves to guide the resulting edge flow, so we can have a lot more control. It's still an automated tool, but it takes user input to help guide the output of the automated process. And that's an important thing to understand. If you want total control over your topology, you'd need to use the topology brush. You'd need to use edge extrusion or Z-sphere topology, or an external retopologizing tool like QuadDraw in Maya. So let's take a look now at how we can use ZRemesher guide curves and tweak some of our settings to have more control over the resulting topology. So here I've opened an Alien Z tool, and I'm going to delete my lower subdivision levels, go into frame mode, and you see we have just a very, very dense mesh here. It's not organized in any particular way. So we want to ZRemesh this, but utilize a bit more user input over the resulting mesh. So I'll go to Subtool, and I will duplicate with the Duplicate button, making a copy of the head. And we'll keep the high res with the polypaint around and just turn off visibility on our other subtools. Now, I'm going to retopologize this character, but this time I'm going to use the ZBrush or the ZRemesher guide curve. So I go to B for brush, Z for ZRemesher, and here we have ZRemesher guides. Click OK. Now, these guide curves will draw on the surface like any other curves, but they will allow us to guide ZBrush on how we want to see that topology laid out. Now, once again, I want to make sure that I've got a clear line on the underside of the eye socket, so I'm actually going to mask out the inside of the eye here. I just want to make sure that we've got a really clear kind of ledge or drop-off point. So there's a very defined plane change here. So we'll just carefully mask these areas out. Now make sure that we do this with X symmetry turned on. Let's zoom in here so we can see more clearly. The reason, again, why we do this is the more defined a plane change, the more likely the algorithm is to place an edge loop there. And we definitely want to have clear edge loops surrounding the eyes. Now, this particular character was sculpted using Dynamesh, and there is no opening for the mouth. We'll talk more about that in a later demonstration, how to add a mouth bag to something. But I just want to show you here how we can retopologize using curves. So let's Control-click on the background to invert the mask, and we'll take the Move brush. And with the Move brush, I will just pull these faces down, pull them up. Just make sure that we get a real clear line of demarcation. The sharper that plane change is, the more likely ZBrush is to recognize it and then place an edge loop there. There we go. Just make sure it's not crashing out through the front, clear the masking, and there we go. Now I'll go to B for brush, Z for ZModeler, and select the, or excuse me, Z for ZRemesher, and select the ZRemesher guide curves. Now these curves work like any other in ZBrush. A larger draw size draws a larger resolution curve. A smaller draw size draws a smaller resolution curve. If I hold down the Alt key and drag a curve across those, I can delete them. So I will begin by creating an edge loop that runs around the eyes, and make sure that you have X symmetry turned on. So this is drawing on both sides. And then it will snap to that point. Now I'm going to draw an edge that comes out along this underside of that lid there. And we'll draw another edge that comes out through here. Now I'm going to draw another curve that runs around the eye like this, sort of following the trail of the bony landmarks there. And then I will draw a curve that starts here, and we'll create kind of a bandit's mask going around the face like this. Now I'm going to get rid of this point here just by holding down the Alt key, dragging across that to get rid of it. And I'm going to draw a curve that comes up here. And I'll draw a curve that comes down through the furrow here, like so. And we'll do the same around the mouth. I'll draw a curve that runs around the lips themselves. And we'll draw a larger curve that carries the shape of sort of the orbicularis oris muscle. And then I'm just going to drag a line from here up to the eye. And I'll drag a line from the corner of the mouth out to here. And that's going to create a directional change here. Now I can smooth these curves. Again, if I go to stroke, under the curve functions, I can smooth the curves like this, and it will actually smooth out the curves on the surface. I'm going to draw a line from here to here. I'm going to undo that. That's not exactly what I wanted. I want to grab this point right here and draw a line up to here. There we go. So this is going to create a star or a pole in this area. Let's go ahead and bring a curve down to here. Now, the more of these curves that you draw, the more difficult you might make it for ZRemesher to give you the topology that you want. That's something to bear in mind. You can overdo this. So I've got, I think, enough curves for this face right now. I'm going to go to Geometry, ZRemesher, and let's take a look at what we change in our settings now. I'm going to set my target polygon count to 10,000 faces. I'll leave adaptive mode on. Adaptive is at 50. The curve strength is at 50. The curve strength tells ZBrush how much to follow my guide curves. So if my guide curves are set to 100, it will follow them exactly as they are, which sort of defeats the purpose of ZRemesher as a whole. If I turn it down to 0, the lower I turn it, it just sort of, they act like magnets. It will attract the topology towards these curves. So you can tweak the curve strength setting to adjust how accurately the topology is followed by ZRemesher. I'm going to just really quickly get rid of that edge there and bring one over here. And let's see if there's anything else that I want to do here. I think I would draw one more curve from the center line here, encompassing the whole of the face here, bringing it back around towards the center here. Now, let's go ahead and ZRemesh. So I click ZRemesher, and it will start to retopologize, and it's going to base the resulting topology as close as it can on the curves that I've drawn, but it has a hierarchy of concern. The first thing it's going to do, it's going to make sure that it represents the volumes of my sculpt. So the more complicated your sculpture, the harder it may be for you to hit that target polygon count. Now remember, you've duplicated your mesh. You could potentially smooth out areas of high detail just for the purpose of retopologizing it, because you're going to project it back onto your original. So that isn't necessarily a big concern, but the algorithm does look at the density or the complexity of the surface first. Then it looks at your target polygon count and evaluates that based on the adaptive size as well as the curve strength. Now you can disable adaptive size by turning off adaptive, and you can adjust the curve strength by changing that slider. Now there's another option down here we'll look at in a minute called Use Polypaint. We can actually color code areas of the mesh with Polypaint to determine what areas get more density and what areas get less. So here we have our resulting mesh, and you see that we have the loops running around the mouth, we have the loops running around the eyes, we have these loops that come up through the brow ridge, and we have this loop that carries around here. There's my pole there, my plane change, or my directional change there of my faces. So if I were to undo this, and let's try and set it like quite a bit lower and see the difference that we get. So if I go back to my target polygon count and set this to, let's set it to 4,000 faces, which may be a recipe for disaster, but the point of this is to see when you limit the number of faces ZBrush has, it's going to do its best to create the best possible topology for you, and the first thing it's going to throw away is going to be the target polygon count. That's the first thing that it's going to say no to, and it's going to continue evaluating based on the other bits of hierarchy, which is just fine for the purposes of an automated tool. And that's sort of the thing that you have to remember with some of these tools. They are an extension of like an automated process. So if you want something that is specific to an exacting number, then of course you should retopologize by hand. However, the automated aspect of ZRemesher and UV Master, for example, they take so much user input, you have an enormous amount of control, and you can create very usable topology, not necessarily pipeline topology for animation, but quite usable topology very, very quickly. Here we go. Go to frame mode and look what we have here. We have a pretty good result. I'm not terribly keen on this, the way it worked this bit out here. That's not very desirable. So if I undo that and look at my curves, let's see what happens if I were to draw a center curve going straight up here. And this center curve works just like the center curve that we did using the topology brush. If you remember when we did the topology brush, if you have seen that video yet, if you have not, we use the topology brush to draw a center line curve. I'm going to turn my draw size up and just draw straight down the center of the head here to give ourselves an edge flow that runs right down the midline like that. Turn my draw size down, hold down the Alt key and zoom in here. This bit is going to give me some trouble, so I'm going to get rid of that, and I will just carry these up to here. Oops, I don't want those to snap together, so I'll carry this up to here. Make sure I get rid of that one and carry this one up to here. And I'll carry this one to here, and I'll carry this one to here. I'm going to delete those two. I want that to be much cleaner, so I'm just going to carry that one to there. There we go. And just for the sake of interest, I am going to draw a loop around these nostrils. Now, my draw size was too large, so I'm going to turn that down because I need a sort of finer curve resolution to get that shape. So I'm going to turn my draw size down, and I'm just going to draw loops around these nostrils here. There we go. And let's go ahead and put one here as well. Now I will press the F key to focus out, and let's do this one more time. Let's ZRemesh. And there is our finished topology. Go into frame mode so we can see the result. And now we've taken care of that particular issue right there. That's an interesting choice, but it's not really the end of the world. But you can see how you could go in here now and further refine that just by forcing ZBrush to follow those curves a bit more. Let's try that. Let's undo. So that particular polygon count came out at 11,000 faces. It's a bit more than the 4,000 that we had set. So let's go ahead and undo. And let's set our target polygon count to 10,000 faces. And I am going to increase my curve strength. So let's set the curve strength to 55 and then ZRemesh. Here we see the resulting topology. And we're getting a pretty good result. The curves are being followed pretty closely, especially here around the nostrils where we looped the nostril apertures. The eyes are looking a bit better, but still sometimes those edges will go astray. So what happens if we give a different type of input to ZRemesher? What if we adjust the curves, making fewer of them? Let's take a look at that now. So let's take a look at what happens if we reduce the amount of input that we're giving the curves. So I'm going to go to the stroke menu, and I will delete my strokes. Now, instead of doing such an elaborate curve layout, let's say we want a curve going around the eyes. We want a curve going around the larger portions of the mouth here. Turn my draw size down, and let's define a smaller curve around the mouth. Let's put a curve that runs straight out from the mouth like this. And let's do the classic bandit's mask around the eye area here. And let's connect from here to here and from here to here. Now we're just going to use these curves to establish what our network should look like. Now if we ZRemesh it, target polygon count 10, adaptive size 10, and our curve strength set to 55. ZRemesh. And here we have the resulting topology. If we go into frame mode, you can see that sometimes fewer curves can actually be more beneficial than too many curves. So in some areas, we're getting a better result here simply because we've reduced the number of curves and given a minimal amount of input to ZBrush and allowing the algorithm to do the rest of the work. Now, again, I can't stress enough that ZRemesher should really be considered an automated tool. It's, I think, best suited for retopologizing something like a Dynamesh, so we can carry on sculpting with subdivision levels. Anything for a production-ready model is typically going to need to be retopologized by hand, but this gets us pretty far through the process. So let's take a look at one more input vector we have, and that's using polypaint to drive the mesh density of our resulting ZRemesher topology. So I'm going to undo back to our original mesh, and I'm going to go to stroke, and let's delete all of our curves. Turn off frame mode. Now under ZRemesher, we have the option to use polypaint. So I'm going to go to the color white, turn on RGB, and go to color fill object. We're just going to clear the polypaint out of this character. If I turn on use polypaint, I now have this color density slider here. So if I go to the standard brush, make sure that RGB is turned on and Z-add is turned off, it's going to automatically set my value. And right now that value is set to 2. So if you hold down the control key while you're moused over this, it'll give you a tooltip that will remind you that the higher this value is a multiplier, or excuse me, the higher the slider is a multiplier for how much red is applied, and then how many polygons will be applied in that area. So as you go down, it goes towards blue, and then you can reduce the amount of polygons. So if we wanted to have, and we'll make this quite overstated so it's very, very obvious what's happening. If we paint red into the eye area, the nose area, and the mouth here, if I take my color density slider from 2, bring it up to, let's say, 3.1, you see that's giving me even more of a saturated red. If I bring this down to, let's say, 1.5, 1.6, you see it's getting lighter and lighter. It's no longer that same density of red. Then, make sure I get everything marked in here. If I change this down to, let's say, 0.25, now we're painting blue. And anything that gets blue is going to have fewer polygons. So we're going to make this very, very stark in contrast, so it'll be very obvious what's happening. So just paint blue down the neck and under the chin here, and all these blue areas, again, will get far fewer polygons than anything going towards the red end of the spectrum. Now, there have been instances where I found it useful to use polypaint to adjust the topology in this regard, but again, I do have to stress that I often feel like there is a point of diminishing returns. If you need to have this much control, sometimes you might be best off manually retopologizing your mesh, but it is really good to have this degree of user input. So let's go ahead, and I'm going to select that red there just by clicking and dragging across, and I'll just make sure that this whole area gets the most polygons. So we're set to target polygon count of 10. We have adaptive turned off, and we'll set curve strength to 50, even though we don't have any curves, and then ZRemesh. Now ZRemesher is going to evaluate the color coding that we applied with polypaint to drive what areas get the most resolution in terms of number of faces. And here is the result. We have to go back to white so we can actually see the mesh. And obviously, it's really dire where we've painted the blue. We have very, very few polygons in this area. And then the rest of the mesh, we have the unpainted areas, or have the normal polygon count that we were expecting before. The areas where we painted red have very, very tight polygon clustering. So I'll undo that, turn off frame mode. Now let's go ahead and sample that blue And watch what happens if I just paint the blue over everything by going to RGB, Color, Fill Object. ZRemesh again. You can imagine polypaint as being a way to isolate areas where you want to adjust your target polygon count slider. So you can focus in on specific areas and say, okay, I want this to have twice as much as that, 3 times as much as that, or a quarter as much as that. So again, it's just a way of giving further user input to an automated algorithm. And there we go. The result is absolutely unusable, but that's the point. I want you to see just how far you can push down the resulting topological result using just polypaint. If we go back to white, go to Color, Fill Object. Let's undo that, actually. Get back to our original mesh, go to Color, Fill Object. And let's say I want to take my color density, and this time I will set it to 0.75. I'll do Color, Fill Object. Then I'll change to the color white. RGB is on my brush, and then I'll just paint white into the face here. And that way I can reduce the density of the faces that we're getting along the back of the head and the chest and whatnot. Now, it could be quite literal in the way it reads this, so I'm going to turn my RGB intensity down to like 20%, and then I can create sort of a blend here. Make sure that we get that down the neck here as well. Turn it down even lower. Otherwise, it's just going to be a sudden drop-off in the polygon count. So this we'll do one more time, ZRemesh, and we'll see the result of this. And here we go. There is our resulting polygon layout. Let's go to frame mode so we can actually see what we get here. And this is actually a bit more reasonable. So we've got some more clustering of our faces here, and as we get out towards the back of the head, things can get a little bit bigger. It's quite a subtle change, but it does go to show that you can get some subtleties in the effects using this tool. You also see that I'm actually getting a pretty decent edge flow around the eyes here and the nose, given that I've placed more topological emphasis in this area than the shoulders, the chest, and the back of the head. So let's move on from organics now and take a look at how we can retopologize hard surface models. ZBrush in the post-ZBrush 2018 version overhauled all of ZRemesher, so it's got a lot of tools that work particularly well for remeshing booleans and other hard surface models. So let's take a look at that now. So here I've got a hard surface greeble. It's just a boolean model. And if I open up my subtools, you see I have a single folder with a variety of Boolean objects in there. If I turn off Live Boolean, you can see the shapes that are combined together so that when I turn on Live Boolean, I get this form. Now, because I have these in a folder and I've got Booleans applied to them, if I click the gear in the folder, I can click the Boolean folder option, and that will apply the Booleans, hide the folder, and now I've got an actual mesh. So let's go ahead and select this tool here, and you can see the resulting mesh. Now, the underlying topology is not ideal, obviously. So what we can do is retopologize this using ZRemesher. So we'll go to Geometry, ZRemesher, and I'm going to set my target polygon count to 20,000, and I'm going to turn on Detect Edges. Now, I don't have any creases at this stage. If I go into frame mode and zoom in, you see we don't have any creased edges here, so I don't need to keep creases. I could go to creasing and then click crease polygroups, and that would put a crease on the edge of every polygroup here. Because it's a Boolean, those polygroups are a great way to delineate one plane change from another. So we won't do that in this case. We're just going to detect edges, target polygon count 20, and we'll leave adaptive on at 50, and then we'll ZRemesh and take a look at the result that we get. This is a symmetrical model, so it is fine to topologize this with X symmetry on. So let's go ahead and ZRemesh it. And it's quite fast. And there we go. That is an exceptional automated retopology in my estimation. It's a bit heavy. We could reduce our target polygon count, but you will also find sometimes the quality does reduce as you reduce the target polygon count. Now there's a couple problem areas here like that. If we redo that, you see we're getting a little problem there. So if I undo, go into frame mode, just take a look at that. Let's see what happens if we were to crease our polygroups. So let's go ahead and click Crease PG. That creases all the polygroups. Now, so I can maintain those shapes, I might need to increase. I'm going to click Keep Creases. I might need to increase my target polygon count, but we're going to keep creases and see how that fares. So I will once again ZRemesh, and it will run very quickly. And there we go. And that is a better result. So for a single automated button that you press to remesh these Boolean objects, it's a fantastic result. And of course, this is, topology that you could apply UVs to. You could 3D print this. It's quite reasonable to be used. You, like I said, might want to reduce the polygon count somewhat. You can adjust your target polygon count, but again, as we've seen with the organics, as we reduce the target polygon count, it will start to erode the ultimate quality. So there is a balancing act you're going to have to play between your adaptive size, your target polygon count, and whether or not you're creasing edges. So we've got Keep Creases turned on. We have Detect Edges turned on. Let's go ahead and try to turn our adaptive size down. Or let's just turn adaptive size off entirely. Let's set this to 10,000 faces, and let's try one more time and see the result that we get. And there we go. We've brought it down to 18. I'm going to half size it, ZRemesh. And it's quite good. There's a little problem area there, which could be fixed by hand if need be. If we zoom in, you can see that we've got a little bit of an issue right there, where that edge is sort of shooting over in that direction. So if I undo that again, looks to me like we're just running into an issue where we need to actually crease that edge right there. You see, that's not catching a creased edge, because that's not two different polygroups. It is a hard edge, but doesn't appear that that has, oh no, that does have a creasing on that side. So let's just double check and see if we have a crease on this side. It looks like it's creasing that edge there. So what I'm going to do is I'm going to go to my creasing and I will uncrease all. And I'm going to Control-Shift-Click and try and isolate just that particular polygroup. I want to get just that yellow polygroup that's giving us problems. There we go. Now I'm going to go to my polygrouping. And I've got the option to group by normals. Let's see if I can't turn that on. There we go. Now I get a different polygroup for each one of those faces. Now I can go to creasing, crease polygroup, and that's going to crease the edges of every polygroup. So now let's try that retopology one more time. So I've got Keep Creases, Detect Edges, and ZRemesh. Oops, I have half size turned on. Let's turn off half size and set it to same, ZRemesh. And there we go. Go into frame mode. And there is our resulting topology, which is quite good. I think that's a very reasonable poly count for this object. And you can see because we've creased those edges, it now follows those along quite well. That is a very good result, in my opinion, for an automated tool here. And once again, we could half size, but half sizing this may very well be detrimental. You just have to experiment and see on a shape by shape basis. We're starting to get faceting now along our curves. So depending on how featured this particular object may be, that may or may not be an issue. It's entirely up to you and what the ultimate application for this tool is going to be. But there we have retopology for hard surface objects, and it's it's shockingly simple, I believe. I think it's really, really well done in the new version of ZRemesher. As I said, ZRemesher was rewritten. That's why we have the legacy button here. So after 2018, it was rewritten from the ground up, and it gives us this type of control and this type of quality when we're remeshing the result of a Boolean operation. So I hope you've enjoyed this video on ZRemesher. This is a pretty in-depth dive on the tool. And I just want to stress again that in my own workflow, I use this to retopologize and clean up Boolean objects, and I use it to take a Dynamesh mesh and turn it into a subdivision model. And we have an entire video where I show that process, and I've shown it a bit in this video, and there's another couple places where we use it. I repeat it throughout the course because it's so important, I think, to the ZBrush workflow. When you're sculpting organics, you want to have subdivision levels, and ZRemesher is a key part of the stage to take something that has that started as a Dynamesh, give it subdivision levels, and capture all your high-resolution sculpting in those subdivision levels so you can carry on sculpting with the benefit of having multiple levels of resolution. So I hope you've enjoyed this video, and I'll see you in the next chapter. Thanks for watching.